Hello guys, welcome back to MedZone African Motives, still on our revisions for power machines and six. And this is we are a question that you're going to consider, that is August 2023 exam. All right, on the internal combustion engines that we have, that is the first part on 5.1. We are given what is the difference between the 95 unleaded petrol and the 93 unleaded petrol. What are the differences that we have? All right, so as we understand our different types of petrols that we're given here, they can be referred in terms of the octane number. All right, so we can talk about the octane number. All right, so there we've got the octane number, which can be considered to be the 95 unleaded. This one is gonna have a higher octane, so it has got a higher compared to the 93. All right. Also, you are going to consider the octane rating. So you've got the octane rating in that case. So in terms of the rating, the 95, it has got a lower rating compared to the 93 unleaded petrol. And also we talk about the color. You can consider the color to be involved. That is the color in this case. All right. So the 95, you will find out that it is a dyed green, this one. It is dyed green. Whereas the 93 is something like a dyed yellow. So this is dyed yellow in terms of the color. Then also in terms of the cost, you can consider the cost. Those are the differences that you need. And also the resistance to auto ignition, that can be also considered, the resistance to auto ignition. All right, so that is the resistance to auto ignition indicator. So that is, you can consider one of these in terms of your ratings or in terms of the differences between these two. So I also try to give you guys how are they differing in terms of the color, in terms of, all right, in terms of the cost. The 95 is expensive, depends, but mostly the 95, you find it mostly expensive, all right, compared to the what? To the 93. All right, that's 5.2. We are given now a 4-cylinder, take note, a 4-cylinder, 4-stroke. So the first thing that you consider there are the number of cylinders, 4-cylinder. All right, so remember E representing the number of cylinders, that is E is equal to 4. That is the number of what? The number of cylinders. And it is a 4-stroke. All right, there we are given that it is a 4-stroke. Remember, I said this issue of the 4-stroke, it affects the speed. When you are given here the speed, that is when it is affected. They are saying it is running at a speed of 1,947 revolutions per minute. So it affects our speed there. How? When you're given a 4-stroke, our N is going to be considered as the revs per second divided by 2. Remember, I talked about this. Then when you are given a condition that is a 2-stroke, it's revs per second over 1, meaning to say you just take the revs per second as they are. But this time it's a 4-stroke. So meaning to say we are going to take our speed, this one, to be written in revs per second. So it's going to be given as a 1,947 over per second is going to be over 60. This is per minute to convert to be per second. But take note, there's these two also to be considered. The 2 here is for what? A 4-stroke divided by 2. All right, a 2-stroke divided by 1. That is the idea. Then what else are we given? We are given that here with a brake arm of, so this is the radius that you're given from the arm. All right, so this is from the center to the arm. So this is the radius that you're given and the mass. So this is going to help us to calculate what? To calculate the torque. So you're given the radius. In this case, we have got a radius of that is 1,092,31 in millimeters. Remember, this is supposed to be in meters. So you have to divide by 1,000, and that will be 1,09231 in what? In meters. And the mass load, meaning to say we also have the mass there. So that is, we have got the mass load, which was given as 12,967. That's 12,967 kilograms. Okay, so this was tested while running at a speed of, I talked about the issue of the speed, how it is affected with the number of strokes. All right, this affects your N, and you'll see that when you're calculating your power. All right, then the brake thermal and mechanical efficiency were, so we've got the brake thermal efficiency and also the mechanical efficiency respectively. All right, so that's, we've got the brake thermal efficiency in that case. All right, so remember, sometimes they'll ask you to calculate this, but this time we are given, and also we are given the thermal efficiency. So these are the two efficiencies that you're given. So the mechanical, not the thermal. This is the brake thermal and the mechanical efficiency. These are the efficiencies that you're given, all right? So the brake thermal, that is, we are given, this is 26.01, and the other one, 79.11. So you just take your values as they are. So the first one we saw, it was 26.03, which is percent, and the other one was 79.11%. Then what else do we have here? Then the exhaust gases with a specific heat capacity. So this is the specific heat capacity of what? Of the exhaust gases, were found to be at water, which is 511.96 degrees Celsius water, meaning to say there is a change in temperature from a certain temperature. Now it has increased its temperature. So we're given the specific heat capacity and also the change in temperature for the what? For the exhaust gases in that case. All right. So for the exhaust gases, we are given the specific heat capacity. So I'm just going to write it like this. Sorry for that, like this. And also we are given the change in temperature. It is now hotter or it is cooler. All right. It has increased its temperature. So the specific heat capacity 1.1 and the temperature increase. Those are the values that you're given. So this is 1.1 kilojoules per kg Kelvin. And remember, the temperature was given as 511.96 degrees Celsius, which means the change in temperature for the exhaust gases. And also we are given that the fuel used during the test. All right, sorry, before that, we had got the air fuel ratio was this. All right, so that is the air fuel ratio. Gonna explain this one later on, the air fuel ratio. All right, so the air fuel ratio is given as 18.25 as to 1. So this is 18.25 as to 1. And also we have got the fuel used during the test. It got a calorific value. So this is the calorific value of the fuel, 43.86 megajoules per kilogram. So like I said, guys, when using this, you're gonna use it in kilojoules per what? Per kg. Unless stated otherwise, maybe your answer is needed in mega something. That is where you have to use the megajoules. But in calculation, you're supposed to use the kilojoules per kilogram. And this is mega, which is 10 to the exponent of 6, which is same as 10 to the exponent of 3 times 10 to the exponent of 3. So this one is going to represent the kilojoules per kilogram. What about this one? It is going to multiply these values. It's going to be 43.86 times 10 to the exponent of 3. So that is the calorific value, 43.86. 0.86 times 10 to the exponent of 3, which is now in kilojoules per what? Per kilogram. So that is the idea there. So with this information, we can be able to calculate anything. So the first question was to calculate, take note, let us be careful about the questions that you're given. One, they need us to calculate the engine torque in Newton meter. So we need the torque of what? of the engine, that's 5.21. So the torque of the engine, as we know that we can calculate that from the force and radius. We've got the mass, yes, but we can use the force times radius concept, all right? You've forgotten this, you can use your formula sheet. If you check here from your formula sheet, if you are to calculate the brake power, you're also given the formula that you're supposed to use to calculate the torque in this case, which is force times what? The radius. That is force times the radius. So we've got the force that can be calculated from the mass, because we've got the mass here. So remember that force is equivalent to mg, which is mass times the gravitational acceleration. So this can be written as mgr, like that. That is the mass times the gravitational acceleration, the mass of 12.967 times the gravitational acceleration of 9.81 times the radius, which is given in meters as 1.09231. Like I said, guys, this is supposed to be in meters, the units. Remember your units in Newton meters. So this is supposed to be in meters. So if you were to simplify this properly, you are going to obtain the value of the torque in this case, and that was going to give us 138. So this is 138, sorry for that, comma 947,947,4087, like that. So it's going to be 947 to 3 decimal places, and that is what? In Newton meter. Okay, sorry for that. So that's going to be something like this in Newton meter. That is, we have got what? We have got the torque in this case. Okay, let's see. But do they want the torque only here? No, they also need the brake power in kilowatts. All right, it's because we have got this formula for the brake power. If you consider the previous question that we had, I used the formula. There were so many formulas, actually, like I said, to calculate the brake power. There's so many formulas, but let's check on this one, because now we've got the torque, so you can use this formula. But in our previous class, remember, I talked about this formula for brake power using the brake mean. When you're given the brake mean effective pressure. But in this case, do we have that? We do not have. But we have got the torque in this case, we've got the speed. So using this formula, we can be able to calculate what? Our brake power. So that is the best formula that we have in this case. So sometimes they will just ask you to calculate the brake power direct, and you'll be forced to calculate the torque. But in this case, they ask you to calculate the torque first, then they need you to calculate the brake power. So as we saw from our formula, this is 2 pi times Tn over 60. Okay, so that is our brake power in this case, which is 2 pi times T, which is the torque in this case. We've calculated this, 138,947 times the speed. Once the 60 is given there, it is a sign of conversion from revs per minute to revs per second. That is the purpose of this 60, to convert the speed in revs per minute to revs per second. So in this case, there's no division that you're making like this one. Is when you are calculating what? The indicated power. The moment you are using the formula for the plane, or those ones, we use the formula for the place. That's when you use this N this way. But if you are using this formula for the brake power, this one, you use the N that you're given in revs per minute as it is, meaning to say we are taking 1,947 revs per minute as it was before. All right. So this is 1,947 revs per minute over 60. So the over 60 that we are seeing here, like I said, is for converting to revs per second. All right. Why converting to revs per second? So that we obtain our power as the kilojoules per second. All right. In actual sense, this one is not going to be in kilojoules, because these values are not in kilo something. It's just going to be joules per second, which is equivalent. Remember, joules per second represent what? Watts. Okay. So that is why we have to convert to per second. So if you have to calculate this, this is what you're going to obtain. That is our brake power is going to be given. You're going to obtain something like 28,329,81535, something like that. So like I said, this is joule per second, which simply means what? Our answer is in watts, not kilowatts. So to convert now to kilowatts, because we are asked to calculate this in kilowatts. So what are you going to do is either divide by 1000 or we multiply by the opposite, which is times 10 to the exponent of what? Of -3. By multiplying by 10 to the exponent of -3, the answer that you obtain direct on your calculator will be in kilowatts. So on your calculator, you're going to obtain 28,3298, something like that. So this one is going to change 3 decimal places. It's going to be 3, 0 like that, kilowatts, all right? So you can even fix your calculator to 3 decimal places. So it's going to be 28.33 kilowatts, or you can put the 0 if you want, or just leave it like that. That is how you can calculate the brake power. We do not have the brake effective, like what we're given before, where we're given the brake mean effective pressure. So this is the best formula. So you see, it depends with how you are given the question. So you just have to play around with your information as you are revising. That is the best thing that you can do. All right, so let us check. I don't know if we are going to need this talk that you're given here, but in case that we are going to need it, we're just gonna remember our answer. All right, let us not forget our answer because I need this space here. So the next question was to calculate the rate of flow of fuel, that is in kilogram per minute, and at the same time the exhaust gases in kilogram per minute. So we need the rate of flow of what? Of fuel, and that of the exhaust gas in kilogram per minute. All right, this is what we need. The rate of flow of fuel is given, we know this as, okay, let me just write this as 5.22. So the first thing that we are considering is the rate of what? The rate of flow of fuel. What are we considering there? Fuel. So meaning to say we're talking about the mass of fuel. But the mass of fuel per minute, because it's needed in kilogram per minute. So they need this per minute. All right. The mass of fuel, that is the question that we're given there. So what we need is that, is there any appropriate formula that consists of the mass of fuel from what we have? Or from whatever that you're given, is there any formula that consists of the mass of fuel? Yes. Remember, we had this from our previous, from the other question that I talked with you, where we had to calculate this brake thermal efficiency, if you still remember. And when we calculated that brake thermal efficiency, we used the mass of fuel as the mass of fuel per second. Okay, let me take you to the formulas. You might think that is something that we never talked about. If you still remember these formulas. All right, where is that formula? I think it is here. All right. If you still remember, when I talked about these two formulas here, indicator thermal and the brake thermal efficiency, these ones. So if we check there, because we have got the brake thermal efficiency there. So meaning to say we can work with this one, the mass of fuel per second. Because we have the brake power, the calorific value, we do not have this. And from this formula, it is mass of fuel per second. So do not forget that, as it is given from a formula sheet. Okay, from our formula sheet, it is stating that the brake thermal efficiency, which is this one that we are given here, can be calculated as the brake power, which is the one that we calculated. That is why we have to take advantage of this formula. The mass of fuel per second times the calorific value. I talked about these formulas before, and that represent, we're just going to remove it and divide by 100 there. All right. I talked about this formula before, and I said, please understand this. The brake power in kilowatts representing kilojoule per second. So this must be in kilowatt. The calorific value is given in kilojoules per kilogram. That is what? Calorific value. And this is the mass of fuel, which is given in kilograms per second. But they need this in kilograms per minute. So meaning to say, our first answer must be in kilograms per second. Then we can convert it to kilograms per minute. That's it. That's it. That's the idea there. Okay. So we can make this the subject because that's what we want. The rate of flow of fuel, which is the mass of fuel per minute. But according to this formula, it is measured kilograms per second. Okay, let us just make it the subject. As you are going to cross multiply, you're going to have this times this times this. So in order to remain with this on the other side, it was going to be the mass of fuel per second is equal to the brake power, the one that you multiply by 1. So it's going to be brake power over these other two that way it was with, because you cross multiply, remember? So you would divide with the efficiency and the calorific value. So meaning to say here, we're going to divide by the brake thermal efficiency times the calorific value, as I said, the units. So the units must remain as they are, so that your answer is going to be in kilograms per second. So if I have kilograms per second, how do I convert to kilograms per minute? Because I can do that on this formula. So it's going to be like this, the mass of fuel per minute now. Take note where we are. We are in kilograms per second here, mass of fuel per second. So you can even convert it on your formula. So it is just going to be this brake power over the brake thermal efficiency, all right, times the calorific value times what? 60. Remember, 1 minute, 60 seconds. So we are supposed to divide by 1 over 6. To divide by 1 over 60 is to multiply by it on top. It's 1 over like this, 1 over 60. So it is to multiply by it on top. So this means the rate of fuel there is now given in what? Fuel per minute. Our answer is going to be in kilograms per minute. That's the idea there. Your answer is now automatically in kilograms per minute by multiplying by 60. Or you can first find the answer. After finding the answer, then you multiply by 60. It's up to you. All right, so that's it. So that is the mass of fuel per minute is going to be given as the brake power. Remember, we calculated the brake power. Like I said, it is needed in kilowatt. And in kilowatts, that is 28,33, which is 330 there, which is just 33. Everything over, remember our brake thermal efficiency that we had. Our brake thermal efficiency we are given. This is what we are given here. The brake thermal efficiency, just going to write it as a decimal, 0.2603. because we have removed the 100 already. So that's 0.2603 times the calorific value are given. Remember, that's the one that I said, 43.86 times 10 to the exponent of 3, if you still remember this one. All right, so we've got this in kilojoules per what? Kilojoules per kg. So that was 43.86 times 10 to the exponent of 3, which is simply 43,860. Or you can write it as an exponent like that, times 60. That is to obtain our answer in what? In kilograms per minute. So definitely our answer there is going to be in kilograms per minute. Okay? Or like I said, you first calculate this, you obtain your answer in kilograms per second. You are going to obtain something like 0.002481, something like that. It will be kilograms per second. Then you multiply by 60 to convert to kilograms per minute, or you just multiply direct by 60. Still, you're going to get the same answer, which is 0.148886, something like that, which is 14923 decimal places. And this will be kilograms per what? Per minute. Remember, I talked about this conversion to change to be per minute. Or you can calculate your answer in kilograms per second, which is this. then you multiply your answer by 60. Still, you get the same answer. That was the idea of this question actually. All right. So it's a manipulation according to what you're given. What are you given? Which information are you given there? That is the information that you use. So you find out in another question paper, you might not be given like this. You might not be given like this. All right. So it's a manipulation that is happening. So remember this. All right. So here, let me just write our break power. Remember, this is 28.33 kilowatt. I'm just going to use this space. All right. Let's see another question that you're given. So this is how you play around these typical questions. So now they want us to calculate on the same part. Remember, these were two questions here to be calculated. The other one was the exhaust gases, which is kilograms per minute. So how are we going to calculate the rate of the exhaust gases, which is the mass of what? The exhaust gases. All right. So it follows that this is what you're supposed to take note into consideration. We are still having a continuation there. So we need the mass of what? Of the exhaust gases. This is the one that we need. But it's still in the same unit, in the same kilogram per minute, which is the rate, kilogram per minute. All right. So it follows that the exhaust gases are taken from the mass of air and the mass of fuel together. If you add these two, we are supposed to obtain the mass of what? The exhaust gases. The mass of air and the mass of fuel. So according to the ratio that you're given here, because remember you're given the air-fuel ratio here. What does it mean? Air-fuel ratio. So the air-fuel ratio means that we have the mass of air according per kilogram of fuel, we take it as 18.25. As the mass of fuel will be at 1 kilogram at that moment. So in order for us to now have the mass of the exhaust gases that we are talking about, what does it mean? It simply means we are going to multiply this. We are going to add these two and multiply to the mass of fuel. Okay. This is what we can have. We can formulate an equation in terms of the mass of air and the mass of fuel, which is fine. We can formulate an equation from there. I'm not saying it's wrong, but we can use the ratio that we're given direct as it is. We can apply our ratio direct as it is. All right, so this is the application that we are going to do. We are going to take this when using the ratio. Okay, let me put it this way. When using the ratio direct, when using the ratio direct. So this is what you do. You take the ratio as it is, that is the mass of air plus the mass of fuel according to the ratio. But you are going to multiply to the mass of fuel. That is what you're going to have. Take note. All right, guys, we have to be careful there. According to the ratio, this is what you're going to have, according to this ratio. So what does it mean? We are simply adding. So that means, therefore, the mass of the exhaust in this case is simply going to add 18 plus 1 in this case. So that's 18.25 plus 1 like this times the mass of fuel. Not this 1 kilogram, no. This was from the ratio. The mass of fuel that we are considering is the one that is taken direct. Remember, we had the mass of fuel before this was given. The mass that we are given, the mass of fuel, that was 0 point. We had this, guys, if you still remember, I wrote this value somewhere. Or is it me that I skipped the value? or maybe I removed this value. But remember, we had got the mass of fuel, which was given as 0.149. All right. Did I skip something, guys? You see this thing was of writing a lot of things at the same time. You see, guys? All right, here. Let us check what I'm missing here. There's something that I'm just missing. The mass of fuel, the brake power, or the calorific value, and this is 1814.1. All right. So this is given as guys, I don't know why am I missing this value here? Why am I missing my value? All right, let me just check this properly. Okay, sorry for that. Remember, I erased this value for the mass of fuel. That was 0.149 kilogram per minute. So guys, it's because guys, your paper, there's a lot of things that I have to consider here. So sometimes I end up erasing something that I need. But if you still remember, on our calculations before, it was 0.149. All right, that was 5.22 on question 5.22. We calculated this in kilograms per what? In kilograms per minute. So why are we writing this the kilogram per? Because our answer is needed in kilogram per minute. So we have to use the one that we calculated in kilogram per minute. So like I said, guys, this one, we had this value. So be careful on your information. So that was going to be 19.25 multiplied to 0.149 like this. So this is going to give us 2.86825, something like that. 2.86825. So it's going to be 2.868, just like that. And that is in what? Kilograms per minute. So this will be in kilograms per minute. All right. So that is what we are going to have in this case. All right. So you see these things of erasing, guys, sometimes I'll end up like not seeing where is my information. But that is the idea there. We calculated that value for the mass of fuel before. So you're just taking that value as it was before. All right. So remember, we had that value before. No problem. Let us check another question. So that means here we've got answered two questions at the same time. The rate of flow, that was for the exhaust gases, and the one for the fuel, and the one for the exhaust gases, 6 marks. Okay. Let's check 5.23. The heat lost with the exhaust gases in kilojoules per minute. 3 marks for that. All right. So the heat lost to the exhaust gases, remember we've got the mass there. And the heat lost, guys, is just simple here. All right, no problem. Let me just explain this way. We remember we've got the mass of the exhaust gases here. So it's easier for us to calculate what the heat lost to the exhaust gases. All right. From this part, this is 5.23. So we can just write as Q exhaust gases, which is the one that is lost to the exhaust gases. Given the mass, in fact, here, because we've got the mass of the exhaust gases per minute, it is also needed in kilojoules per minute. If we check, we've got the specific heat capacity, of what? The exhaust gases here, and also the change in temperature. Remember, whenever this is given, we are supposed to think of Q, which is equal to the mass times the specific heat capacity times the change in temperature. But this is the mass of the exhaust gases, the specific heat capacity of the exhaust gases, and the change in temperature for the exhaust gases. So that is what you have to consider now on your formula. So that is the best formula because we've got everything there. So that is the mass. Like I said, it's going to be the mass of the exhaust gases times the specific heat capacity of the same exhaust gases times the change in temperature of the exhaust gases. So we have got everything in that case. The mass is the one that we calculated in kilogram per minute, so that this gives us the energy in joules per minute, kilojoules per minute. So that is 2, 0.868 times the specific heat capacity for the exhaust gases, which is 1,1 kilojoules per kilogram kg. So that's 1,1 times the change in temperature. We are also given that it was 511.96 water. That is when it is hotter than what it was before. That is the change in temperature, 511.96. So that's it. That's it, direct like that. So that is the Q for the exhaust. And this is going to be 1,615,131408, something like that. So this will be 131 to 3 decimal places. And that is measured in kilojoules per minute. Since we used this in kilograms per what? Kilograms per minute. So it means if they wanted us to have this in kilojoules per second, this was supposed to be converted to kilograms per second. So the mass here, it controls your final answer also. Kilograms per minute, kilojoules per minute. If they can say kilojoules per hour, meaning to say use the mass of the exhaust in kilograms per hour, you answer the question how you are given. That is power machines for you. All right. That is the idea of these questions. You just have to play around with your questions, all right? Use the formulas wisely or properly. Then you just have to consider everything taken properly according to the formulas. Then also here, they want us to calculate the percentage heat lost due to friction and the percentage heat lost with the exhaust gases. So there's a percentage of heat that was lost due to friction and the percentage of heat lost with exhaust gases. Okay, how are we going to have this? Okay, I want us to consider this part. Remember that, okay, there are a lot of things that I need here. Let me just hope you understand me on this one. Let me just try to remove this information first. All right, let me remove this one here. Okay. So if we are to consider our question, they want the percentage heat loss due to the friction. Due to the friction, the percentage of the friction power is given from the power that affects, which is our friction power, everything over the mass of the fuel times the calorific value. Okay, let us talk about this formula here. Let us talk about this formula here. We are saying we can be able to find the percentage of the friction power. But we need the friction power to the mass of fuel times the calorific value. So the question that you're asking yourself is, okay, definitely this is a percentage you're going to multiply by 100%. But the question is, where are we going to have this friction power? Remember, the difference between the indicated power and the brake power is our frictional power. So that means we've got PF from there because we have got our indicated power and we've got the brake power. We have these values. All right. Our indicated power, remember, guys, we calculated that was, guys, the problem that I was erasing my values, but that was 35.881 kilowatts, and the brake power was 28.33 in kilowatts. So that was going to give you 7.481 in kilowatts. So this is our frictional power. So the question is, when this mass of fuel is used, it is used in kilograms per second. while is the calorific value, as I said before, is the kilojoules per kilogram. And this is in kilowatts, representing what? Kilojoules per second. Okay. So do we have the necessary information now to answer our question? Yes, we can insert our values. In this case, we're having the indicated power. All right, guys, it's because I had a lot of information here. I think next time I just have to branch these questions 1, 1, 1, 1, 1, 1, 1, 1. All right, the power that I had was 28, but the indicated power I had not given. All right, so I'm just giving you the answer that I calculated. Let me show you how I calculated this indicated power from the mechanical efficiency that we are given. Remember, mechanical efficiency is the brake power over the indicated power. I'm just going to remove this. Guys, now let us hope you follow, guys, because there's a lot of information, as you can see. So like I said, this one, the indicated power here, we are not given. We had this brake power only. We calculated this before. I still remember I calculated that one. But this one, we have to calculate it. So from our mechanical efficiency, remember we said before, there's a brake power over the indicated power times 100%. So we're given the mechanical efficiency already, which is our mechanical efficiency is 79.11%. So that's 0, as a decimal, 0.7911. All right, so that's 0.7911, which is equal to the brake power, which is the one that we are given here. We are given the brake power, 28.33 kilowatts over indicated power. So that is, we can be able to calculate this. If you cross multiply, then you divide, that's 0.7911 times the indicated power is equal to 1 times this, that will be 28.33. Remember, this power is in kilowatts. So the moment we divide by 0.7911, 0.7911, it means our answer is going to be in what? In kilowatts. So that is our indicated power. Just like that. So that is the one that was going to give us 35.8. It was going to be 81089. So it's going to be 811 to 3 decimal places in kilowatts. So with the indicated power that we calculated here, this is the one now that you were going to use to calculate what? This one, to calculate the friction power. So you might be wondering, where am I getting this answer? So now that I have the frictional power, I'm just going to substitute into the formula because the percentage is given from this formula, as I stated before. So that's the percentage of the frictional power is going to be the frictional power that we calculated in kilowatts. That is 7.481 kilowatts, everything over what? The mass of fuel per second, which is the kilogram per second. And if we check for the mass of fuel, remember that is the one that I also erased, but it was given as, from our calculation, we calculated it as the mass of fuel per minute. It was per minute on our answer, and it was 0.149 kilograms per minute. That was the mass of fuel per minute, if you still remember. So now it is needed per second. So per second is either you're going to divide by 60 or you multiply by 60 on top here. So it's either you're just going to write as it is like this, the mass of fuel per second, 0.149 like this, which is the kilogram per minute. You divide it by 60, it will be kilogram per what? Per second. Just like that. Times the calorific value. I said this is needed in kilojoules per kg. So we had this as 43.86 times 10 to the exponent of what? Times 10 to the exponent of 3. Or simply, you can just multiply direct, or you can use times 10 to the exponent of 3. It's up to you. Then everything you're supposed to multiply by 100%. So that's it. We are going to have our efficiency. I mean, the percentage in that case. And that is going to be 6,8684, something like that, which is 868 to 3 decimal places, but it was 6,866,840, something like that. So that is how we were supposed to play around with this question. It's only that, you see, most of the information will be hidden there, but I just hope you are following, guys, because, and these questions, they are so, like, we have got a lot of things, so you end up like, if I try to remove something, it is important, so there's no way I can remove anything, because one thing you need it to another. Then also they need the heat that was lost to the what with the exhaust gases in this case, the percentage actually. So it is the same thing or the same formula, just like this part. All right. Let me just write it aside here so that we can see, or we can relate next time when we are answering that it is the same formula, or it is the same idea. So when it is the percentage for the exhaust, is going to be the formula that you're going to take is this one. The percentage for the exhaust is going to be the Q for the exhaust, just like the friction. If it was the percentage for the power, frictional power, you use the frictional power. So it is the percentage for the exhaust. You use what? The energy for the exhaust. Then remember, energy is power. Energy, power, over the mass of fuel times the calorific value times 100%. So as you can see, the only thing that is changing, or the only thing that is what you're having for the percentage of the frictional power, percentage of exhaust, power of exhaust, which is the energy from the exhaust. That is the exit from the exhaust gases. Just like that. Just like that. And remember, we calculated this energy from the exhaust. It was question this one. The heat loss to the exhaust gases 5.23. We calculated that one. So this one is just a continuation so that we do not waste much time, guys, because as you can see, we might not be able to end our class because I have a lot of information. So this is Q exhaust, which is, we calculated that it was kilojoule per minute. So it was 1,615,131, if you still remember. That was 131. And this was kilojoules per minute. So the units are important. Let's see how are they going to cancel over the mass of fuel. So in order for these to cancel, the kilojoule per minute, it means the mass of fuel, we are supposed to use the mass of fuel in kilograms per minute, so that the per minute cancel, per minute part. I want the per minute to cancel. So we are not going to use per second like this one. We used per second. All right, because of what? Remember, so I told you that kilowatt means what? Kilowatt means kilojoule per second. So you need to cancel per second with the per second here. All right. So that was the idea there. Let me remove this. But here on this question that we are, is the Q for the exhaust that we calculated. Remember, for the exhaust, it was kilojoules per minute. It was kilojoules per minute. So it means the mass of fuel is supposed to be in kilograms per minute also. So that per minute and per minute, this one will cancel. They must be the same. So we are supposed to use the mass of fuel, the one that we calculated direct as it was, and that was 0,149 in kilograms per minute, times the calorific value. Remember, that is 43,86 times 10 to the exponent of 3, or you can use it as 43860. All right, that is it, times the percentage to convert to 100 to percentage, that is times 100%. So that was going to be 24,7145, something like that, which is 71455.8, which is 715 to 3 decimal places as a percentage. So this is the percentage that is lost to the exhaust. You use the information according to how you are given your information from the other part. So the use of formulas, units, that is the basis of our power machines, formula and units. It's not just to know the formula, no, but also the units. How am I going to present my answer? So you need more practice, more questions. So we shall have more questions to come, typical exam questions, and also introductions. When we've got time, we're going to work more introductions also, so that you also understand where it was taken from, each and every part. But for now, that's it, guys, from Maison African Motives. Till we meet again.